I think this person did it wrong just because they thought that was a minus sign there. I apologize, that it was very unclear that should have been a plus sign. And so when you look at the problem, it then becomes more clear that you would use substitution for that, because the derivative of this baby function in here would give you guys that expression. Now, in period 3, I did go over a few problems on this worksheet. Is there any problems that you guys would like me to work through with you guys that you want to see? Maybe me do the work for it to get a better idea of how to do the problems, or just as a refresher. And as you guys do that, actually, let me take the questions first before I ask you this next question. Okay, so there's a request on the same one that the other period had. So let me go through that one with you guys. Number 5, I will do, and then someone mentioned 11. Okay, so number 5, let's start with that one. So you guys, the basic run through of every integration problem that you do is going to be that you try basic integration. And then if it's not basic integration, you're going to want to try, hold on, let me come back to this question. Let me double check the answer key for that. Okay, so 5, you're going to try basic integration, not going to work here. Use substitution, not going to work here, because if you let u be equal to ln of x, you don't have a 1 over x within the integrand that you have here. So that leaves you guys with integration by parts. So in the case of integration by parts, you should kind of like breathe a sigh of relief. Oh, it's integration by parts, because then it kind of gives you a clear direction to go in. You think of I late, you think of what you would let u be equal to in this situation where you're doing integration by parts. And since you really just have ln of x squared and dx as your functions, then u would be equal to your, I would consider 1 dx an algebraic, 1 being a constant. So L is going to be your log function, and that comes before algebraic, so ln of x squared. And for these problems, I think what I'm going to do is start you guys off and just make sure you know where to go from here. dv is equal to dx. So when we're doing integration by part, the left-hand side we're going to derive, the right-hand side we're going to integrate. So on this side, you guys have du equals, that's a chain rule, so 2 ln of x times the derivative of the baby function, which is 1 over x. On the right, you guys are going to integrate. So v equals x. I forgot to attach the dx to the end of my du. All right, so if I were to rewrite this, this is the integral of ln of x squared dx is equal to uv, ultraviolet voodoo. So uv, I'm just going to go ahead and put the v in front just so it looks a little bit prettier. So that's my uv minus the integral of v du. Okay, so look at your v du. What I do is I look ahead of time. If there's a constant like there is here too, I'm going to pull that constant out. And then we have ln of x, 1 over x, dx times x. So we see that, and I forgot to have my x here. Okay, so we see that the 1 over x is going to cancel out here. So the x's cancel out, and you guys are left with minus 2 here, ln of x dx. And my question to you guys back here is where I'm going to leave you. Can you guys type into the chat, where do you guys think you go next with this problem? Where do you guys think you go next with this problem? Okay, good, Heather. Yeah, there only could be one possible thing to do here. If you guys get stuck here, you would realize that you would then have to do another integration by parts on this section. So I would say do another integration by parts, and don't forget to times it by -2. Again, you have a similar situation as the original problem, where you're going to let u be equal to ln of x, and then dv be equal to dx. So for your second iteration, u is going to be ln of x, and dv is going to be equal to dx. I would say it's important that you guys perhaps if the ln of x squared was difficult, that you guys definitely for sure, this is something I could see on the AP test, that they just do the integral of ln of x dx and then make sure you understand that it's integration by parts. There's a student that I know of in third period who never gets the problems really incorrect, but he asked me, well, isn't the integral of ln of x just equal to 1 over x? Why do we have to do integration by parts? What was his, why was his reasoning wrong on that? He asked me that in the chat. Isn't the integral of ln of x just 1 over x? Why do we have to do integration by parts again? What's wrong with that reasoning? Okay, someone typed in that's the derivative. That is correct. 1 over x is the derivative. And so the more we do these types of problems, and you know, it's funny because my daughter is on multiplication and division, or multiplication, and she will do multiplication when she means to do, when she's supposed to do addition. And it's the same problem. It's like, you know, when you're doing something consistently, like for us, integration all the time, or I should say we were doing derivatives for a long while, and then we switched to integration. It's like you go back and forth. And no, I don't teach her calculus. I actually am probably doing a bad job of my youngest daughter keeping track of, it's really keeping track of what they have to do. I don't know if you guys have any younger siblings, but boy, they have like 10 million things. And maybe this is how you guys feel and you're just so good at keeping track of everything. But I can barely keep track with what I'm supposed to do for my own classes, that I've been losing track of what they're supposed to be doing. And they have like, I try to nicely and kindly say it, but like they have so many apps going on that it's so confusing. I don't know if you guys feel like that for all of your classes, just like, oh, this class, that class. I'm sure it gets overwhelming, but I kind of wanted to be hands off and let them figure it out. But that was not working with my third grader. She just, there's like 4 different apps for math, and she was like behind on one of them. And anyway, we spent the break trying to catch up on that. So I emailed her teacher. I was like, I'm sorry, I'm focused on my students, and I completely forgot my own daughter. And so I slowly figuring that stuff out. So Tim did ask me a question on number 3. Did anyone else get a different answer on 3? And maybe I posted the, did you guys get, so I think well, actually, let me check my answer here on what I posted. Okay, Tim, you did not get this -1. Oh, is there an extra 4 here? That's not supposed to be here? Is that what it was? No. Yes. You got that answer? Or you got the first term, but not the, okay, let me see. Okay, so can you guys catch what Tim did? Because some people are saying you guys got the same answer as I did. And then Tim got -1/8 for the second term. If you guys see it before me, let me know what, if you think you made a mistake or if we made a mistake. I don't see it, Tim, where you could have gotten, I mean, I see the 1/8. Oh, he got x squared. I'm not seeing it where the mistake could have been. So, oh, you integrate. Oh, okay. Okay, I see what he did. So I think he saw this as x cubed, right, Tim? Is that right? You might have double checked the number. Number 3 should have been over x to the 5th. I think you might have done over x cubed instead of over x to the 5th, because it does kind of look like a 3 if you're not zoomed in on it. That might be where. No, you weren't supposed to integrate that. You were supposed to integrate ln of x over x to the 5th. Yes, for the voodoo part. So the voodoo part dv was x to the negative 5th. So if you integrated that, you would have gotten v equals negative 1/4 x to the negative 4. Is that which is what you got? Yeah, so v du would have been times 1 over x. Sure, I can keep going. So u would have been ln of x. So du is equal to 1 over x dx. Oh, okay. He figured it out. Does anyone else need me to keep going with that problem? Okay. Good. Okay, so someone else has a question on number 8. Can you verify for that person that you wrote down x cubed ln of 5x? Okay. And for number 8, let me just get to the part where, can you just verify that these are your answers? You got du equals 1 over x dx, and then v is equal to 1/4 x to the 4th. Is that what you got for the initial iteration? Oh, chain rule. That might have been where you went wrong, because u is equal to ln of 5x. So it's 1 over 5x times 5. So it's just 1 over x. Did that make sense? So when you take the derivative of this, okay, perfect. Anything else I can clarify? You guys, I think I did this with the last class, so yes, I will go over 11 with you guys. That was someone else's question. Does anyone need me to go over when to use, because the last class had that question, when do you use tabular, and going over how to do tabular again? Does anyone need me to do that with that, or with you guys, or you're good? Okay, so tabular, a quick refresher on tabular is you can only use it if you have something that is algebraic followed by algebraic for your u. Okay, so in this case, we have an algebraic, which is the x part, and this part is your trig function, right? So we see that this only occurs, like algebraic only comes before trig and exponential. So the tabular integration only can be used if you guys have something algebraic, and then you have either trig or exponential. And the reason is that when you're using tabular and you're letting u be equal to your algebraic, in this case x, and dv be equal to cosine of 3x, that this works out nicely, because only with algebraic, with each successive derivative that you take, you reduce it down essentially to 0. So that's the only time that happens. If it's trig or exponential, you kind of go in this endless loop of functions that do not get any more simple. And then on the right-hand side, so we derive our u's and we integrate our dv's. So the antiderivative of cosine of 3x is sine of 3x. Technically, you're doing u substitution in your head here. The antiderivative of cosine is sine, because the derivative of sine is cosine. And then normally in the derivative, you would multiply by 3. So in which case, when you're integrating, you guys would times by 1/3. Okay, so we do that iteration again. The derivative of cosine would be a negative sign. So we're going to say it's going to be negative cosine of 3x. And then there's already a 1/3 there. We have to multiply another 1/3. So that's 1/9. So negative 1/9. And so I think I'm going to stop there. The signs are plus, minus, plus. The order in which you guys go for the product after that is the x and then plus and then the dv part of it. And then the next iteration would be the 1, the negative, and then the negative 1/9 here. So the next round, if I were to go one more further, 0 times anything is just 0, so we don't really need that portion of it. So our final answer would be x times positive 1 times 1/3 sine of 3x. So you have 1/3 x sine of 3x. Whoops. And then a negative times a negative is positive. So positive 1/9 cosine of 3x, and then plus c. Okay, there's a question on this. Will we ever be required to use tabular? I have never seen a tabular question in the AP test. Like tabular is used just as a, well, let me just say that, okay, let me rephrase that. Tabular is not presented as tabular on a multiple choice question, but you might get a question where it's like x to the 3rd power, cosine of 3x, something like that, in which case tabular is much faster to do than 3 iterations of integration by parts. And given that you guys have a time limitation, if you're doing the kind of like the other way of doing it, the original way of doing it, it might eat into some time. So again, entirely up to you guys, but I mean, if it does come across as a problem like that, it could be a possibility that they give you guys something like that. But again, I think in general, the questions are, you could use either one. They don't force you to use tabular. However, I don't want to say that they won't ever give you guys something where it's like x cubed, in which case tabular is good to know because it's much faster than doing it. And you have a time limitation of 2 minutes for every non-calculator multiple choice question that you have. Okay, so there was another question on number 10. Okay, so this is an important question. I mean, we're going to focus a little bit more on particle motion eventually when we get to the very last chapter of Calc BC, which is on vectors, and this discussion comes up again. So the acceleration of a particle motion along a line is given by a of t. So this is my acceleration, and then I'm given, what is this called, you guys? V of 0 equals 4, s of 0 is equal to 3. What's the equation of s of t? What's v of 0 equals 4, s of 0, what's that considered? When they give you guys something like that. Yeah, your initial condition. So basically you guys have 2 initial conditions, and we have to think about how do we get from acceleration to s of t. So I think I'm just going to start you guys off on this. So if I have acceleration is equal to 2e to the 2t, and I want velocity, and that so that I could eventually get my position function, what I'm going to need to do is integrate, because the derivative of velocity is acceleration. So what I need to do is integrate to get velocity. So if I integrate this, then I have 2, let's say the constant I pull outside of the integral, 2. The antiderivative of e to the 2t is e to the 2t itself, but then I have to undo the times 2, so I'm going to times it by a half here. And then I have the plus c, okay, because you guys are doing first a general antiderivative, then we want to find the particular solution by plugging in v of 0 equals 4. That's going to allow you guys to find out what c is, and then you do the integration once again and plug in s of 0 equals 3 for c. Is that enough for the person who asked for 10 to go from there, or is there a question on a step? So for the person who asked number 10, does that make sense? Okay, perfect. Okay, it would be wise for us to go over the separation of variables, that type of question. Did you guys all see my remind text on the typo that was in this problem? For the person who, or quite a few people asked about 11, did you guys see the remind message about the answer that Nancy pointed out to me? So hold on, let me move this. Okay, so can you guys respond in the chat? The people who asked about 11, is it because you still, even after the correction, couldn't get to this spot? If you still would like me to go over 11, can you let me know? Or if it's because the question is, I had a plus E there. Sorry, no, that's an E. Yeah, if you guys did not match that, can you let me know? And I'm happy to do it with you guys, but someone got E to the 1/2. That for that one person, it might have been that E is still inside the parentheses. So okay, let's just do the problem. So someone said, can we do the problem anyway? Sure. Okay, so we're going to do one eventually where you guys are going to do a practice problem on this, and it's a free response. And I'm going to continue to emphasize you guys on your own test that when you're doing a separation of a variable type problem, they're going to be worth 5 to 6 points. So the first or all 6 points are just automatically forfeited if we don't recognize that we have to separate the variables. So in this case, if you have an expression, a differential equation is something with a derivative and there's x's and y's together, the first move is to separate. So if I cross multiply these, I get e to the 2y dy is equal to 3x squared dx. And then at that point, we can integrate the left and the right. So that would have been 1 point recognized separation of variables, 2 points for each one of the antiderivatives. So e to the 2y times the derivative, the derivative is normally times 2. So the antiderivative would be times 1/2 on the side. And remember, we can do that so long as this is a linear function as the baby. On the right-hand side, if you guys find the antiderivative of 3x squared, it's x cubed times a third. A third times 3 is just 1, so you have x cubed plus c. Okay, so here in some of the homework assignments, I made a note to some of you guys about like, when do you guys plug in the initial condition? I highly recommend that you guys plug in your initial condition at this point. Some of you guys have been going further and trying to get the general solution by solving for y from there. And I think all the operations that you're performing to C can get a little bit, or it could get lost in the process of you algebraically trying to manipulate the equation to isolate y. So what I would recommend that you guys do is at this point, take your initial condition and plug it in so that you can solve for C and find the particular solution. So if I plug in 0 for x and 1/2 for y, I get 1/2 e to the 1 power equals 0 cubed plus c is just c. So c is equal to 1/2 e. Okay, so now I have, now what I do is I would take this formula that I have above, rewrite it, 1/2 e to the 2y equals x cubed plus 1/2 e. So if I go on to isolate y, what I'm going to do is multiply both sides by 2. So in doing so, you guys get, you guys will get e to the 2y equals 2x cubed plus e. And then to bring y down, you guys would take ln of both sides. So let's ln this side and ln this side. And then we get 2y equals ln of 2x cubed plus e. And then divide everything through by 2 to get y equals 1/2 ln of 2x cubed plus e as your final answer. Sorry, guys. Looks like I got dropped. Did you guys see the final answer for that? And I actually, at this point, can you guys also type into the chat, how are you guys feeling for the test? You guys can do it privately to me. And is there a particular concept? I know we're going to move on to logistic growth next to finish everything up, but is there a particular topic that you guys are feeling shaky on? Can you guys go ahead and type into the chat, or do you feel like you're ready for this test coming up on Friday for you guys? I'm sorry, I don't know if I got cut off before, but if you guys want to look at the answer, that's the final answer. So someone asked if we can split this apart, and that was the 2x cubed plus the plus sign in between on an ln you can't split up. So you can't do ln of 2x cubed and then ln of e. So no, that's as far as you can go. Yes, so when there's okay, so someone asked, and I don't want to simplify this to a point where it's not correct. So when you guys are doing reverse chain rule in your head oh, I'm sorry. Yeah, your screen is not showing up because I'm not sharing it. Okay, that was the final answer. I don't know if I got cut off before that, but what I wanted to mention is this step right here that that particular person might be asking about is when you guys are finding the antiderivative of e to the 2y, you're only allowed to do integration in your u substitution in your head. Well, I shouldn't say you're only allowed to, but what I'm doing here is only works if your baby function happens to be linear. So 2y is linear. So when I reverse it, e to the 2y, the antiderivative of e to the 2y is itself. And normally I would have to times by a constant of 2 when I'm taking the derivative. So for the antiderivative, yes, you would just multiply by the reciprocal of that, which is 1/2. Now, you cannot do that if your baby function is something that is not linear. Okay, so let's say you guys had e to the x squared. If you tried to do what we just did by reversing and just going, oh, it's e to the x squared, and I see this a lot, then I just multiply by the reciprocal of the derivative of that. And I try to see if I can match my answer if I take the derivative again. And the problem is that when you guys do this and it's not a constant out front, then what we really when we're looking at this antiderivative, this is really a product of two functions. Okay, one of your functions is 1 over 2x and the other one's e to the x squared. So if I were to take the derivative of this, it would not get me back to this, because when I take the derivative of what's in the box, I would have to apply a product rule, when what you guys just undid was reversing a chain rule. Okay, so again, what is in the part of the exponent here would be the baby function. The baby function must be linear for you to be able to do that. Does that make sense to everyone? That's a really common mistake that I see. You're reversing a chain rule, not reversing a product rule when you guys are doing U substitution. Okay, so I see, okay, so the next thing I'd like for us to do to just make sure that we have time for is logistic growth. And we got a little bit further than the other class on this example 3 that day, obviously, because I went way over the time that I should have for you guys. For example 3, can you guys refresh your memory by looking at that? This is, I think, where we left off. I tried to remember, and let me just make sure we're okay on time here. Okay, in the chat, just to refresh your memory, you guys, what is the value of A if we're talking about P of T as, and let me just clarify something else. At the top here, we had, I think Diana was the one who asked the question, is P representative of population or representative of population infected? And so I said population at that point when we were taking notes, because we were looking at the population of rabbits and then the population of goats before that. But let me just clarify that P of T, it depends on what the situation is asking for. So in the situation where you guys are talking about like the number of goats or the number of rabbits, or basically the population of that, and not about an infection, then P represents their population. As they grow, it's talking about just the number of rabbits or the number of goats. In the situation like we have for infectious diseases, like example number 3, or when we were talking about COVID, P is going to represent the number of people infected. So just a clarification on that. So, and it'll tell you guys the number of students infected by measles is given by the formula P of T is equal to 500 over 1 plus e to the 5.3 negative t. In the chat, can you guys type out what is A in this situation? So I'm thinking of the missing in action formula. What's the value of A in this problem? What's the value of A? Okay, A should be the constant that is in front of E. So when you guys look at it this way, some of you guys are saying 1. When we look at this part of it, we want to make sure that E is like split so that you have e to the negative k as its own factor. So the way that we do that is we're going to split the subtraction, and I think we had shown this step right before we left the last class, is to split it so that it's e to the 5.3 times e to the negative t. And so the value of k is the value that you see in front, and I'll do it in red so it's a little bit more obvious. The value of k is in front of t between negative and the negative sign and then the t symbol. So k is equal to 1. The answer to what a is equal to is it's e to the 5.3. It's the whole entire constant. So yes, e to the 5.3. Okay, and then now if I can have you guys take out your calculators. And please humor me in doing this, and then into the next chapter is, especially in the next chapter when your whole entire free response and part of your test is going to be calculator based. Can you guys make sure you are able to do certain things like this? And I know someone showed up at tutorial after class and said that they couldn't match the answer. And so it looks simple and it looks like, oh, I'll just trust that Mrs. Kim knows what she's doing and I can recreate that on my calculator. It's the subtle differences in each problem and where you put a parentheses or why do I get a syntax error? Those questions I can't answer during the test. So just try this along with me. Okay, so part A, it says how many students will contract the measles during week 2? And so the clarification for this problem is it only wants week 2. So if P represents the population after T number of weeks, then how do I come up with the answer for just week 2 if P represents the population of everyone infected since the beginning of time? And it's the clarification is it's just week 2, just during week 2. What would you guys have to do? You would have to figure out. Good, yeah, you would have to figure out what the population, the number of people infected in week 2 and subtract out from week 1. So very good. So week 2 minus week 1. Okay, so in order for us to do all of this on the calculator, which you guys can, what I'd like you guys to do is input your P function into Y1. So go ahead and enter this function into Y1, and I'll give you guys a minute to do that and put that into Y1. And then on your home screen, you guys will do Y1 of 2 minus Y1 of 1. If you guys can type into the chat what you get, and you can do this all in one step on the home screen, let me know what you guys get. So I can see that you guys got the right answer, or I can direct you guys to maybe where your mistake might have been. So good, Albert, that is correct. Okay, so yes, I think I see. So 11.092 is what a lot of you guys are entering in. That is correct, or about 11 students. That's right. So one thing I wanted to make note of, if you guys aren't getting that correct answer, is did you put this division symbol? If you have a TI-84, the division is nice in that this all appears in the denominator. Can you make sure that the negative sign is not a subtraction sign? If you're getting a syntax error, then this should have been a negative symbol and not a subtraction sign. Also, I'm trying to think of what else could have been a mistake. If you guys have a mistake and you don't understand quite what went wrong, what I'd like you guys to do is take a picture of what you guys have on the Y1 screen and send it to me on Remind, and then I can just double check it. Yeah, so for plugging in values, we're supposed to do second calc value. Oh, okay, so someone figured out their mistake. Yeah, so for the Y1, you guys can do, yes, the correct answer was 11.092. Oh, okay, so I think Heather pointed out a tip for those of you guys who didn't know. You guys can also calculate a Y value by doing second, hit the trace button, second calc, which is above the trace button. And then there's a functionality called value. And it's going to ask you guys, well, what value do you want for the Y value? If you want the Y value at 2, it'll give you guys, you'll enter in 2, it'll give you the Y value for that. That's one option for doing it that way. Kind of get used to using the Y1, Y2 for the next chapter. So the correct answer was about 11.092 or 093. I don't know which one it was, but if we round it to the nearest kids, so about 11 kids. Okay, so the next thing I'd like for us to do is there's lots of questions on the AP test and on your homework tonight, not lots of questions, but let's just say that the types of questions that you guys get for logistic growth is very limited on the AP test. If you get a question at all, it might be a multiple choice question. I've never seen it really used except for maybe a slope field question on logistic growth. But it's really just sketching the slope field and understanding that it's a logistic curve. For part D, you might get asked the question, they throw this in as the idea of a limit as t goes to infinity of your population function or your number of people infected. What do you guys think this answer might be? So consider graphically what the logistic curve looks like. As time goes on, the number of people infected is, what do you guys think it's equal to? In this case, the number of people infected. So in other words, what does it max out at? What do you guys think that might be? You're kind of struggling with thinking about that problem. I want you guys to think about the problem before that, where you guys had, for example, all logistic curves have a carrying capacity. What is the limit? What do you think it's? Okay, so someone said, would it be 500? Because the carrying capacity is 500, yes. Okay, it's gonna max out at the horizontal asymptote, which is the carrying capacity. So if you're looking at the curve, here's 500, and you had an initial condition, it's gonna max out at 500. Okay, so just something to think about as well. We look at a lot of problems where it's under the carrying capacity, but there are situations where you have an initial condition above the carrying capacity, and if I follow the slope field curve, it might look like this. So an example of what that might be is, like, for example, if you had a game preserve and that had resources that only supported 500, or in this case 30 goats, but you introduce 60 goats into it. What's going to happen to those goats? Are they going to continue growing if the resources are only enough to support 30? Would you anticipate that the population over time is going to increase, or would it decrease? What do you guys think if the resources only support 30 goats? Yeah, it would make sense that if your resources are only enough, like food, water is only enough to support 30 goats, if you introduce more to that game preserve, you're going to expect that population to decrease to the carrying capacity that you see here. So you have it both ways for a logistic growth curve. Okay, the last thing I'm going to do with you guys on this one is for part C, it asks when we'll have the students contract the virus. I believe you guys had set up the equation to where it was 250 is equal to P of T. And I just wanted to give you guys the answer to this and then kind of move on to the next problem. The answer some of you had gotten was 5.3 kids. Again, can you, if you're looking at this type of problem, what options do you guys have on your calculator for solving this? What would you guys do to solve for this type of problem? If you're solving for 250 is equal to, Tiffany, that's fine. Yes. Okay, so you're finding the intersection points. Just keep in mind that if you guys have y1 is equal to P of T and y2 is 250, or did I say 5.3 kids? Yeah, it's supposed to be 5.3 weeks. Thank you, Tim. So you're going to look at the intersection point. Keep in mind if y2 is 250, that means it's going to be a horizontal line that goes through 250. So make sure that your windows are adjusted accordingly. And it wasn't Tim, it was Diana. Thank you, Diana. All right, so as I do the next problem, I'm going to give you guys a minute to, if you don't have your textbook in front of you, can you guys go ahead and grab your textbook? Go ahead and get up and go get your textbook. If you don't have your textbook at hand ready, you guys can just look at my screen. But otherwise, if you have your textbook, go ahead and get your textbook and find page 406 for me. It's about a minute to do that. All right, guys, we are on page 406. If you guys can take a moment to read this is all too real, right? We can even cross this off and say spread of COVID. But if you guys can read that little excerpt and then read the paragraph under exercises. This is page 406 in your textbook. By the way, this is part of your homework assignment, so if you guys want to just jot it down on a sheet of paper. Okay, you guys. So I know there's my former students are coming back from, some of them from their off campus, or not off campus, but out-of-state colleges, and some just came back altogether because they were quarantined at the start anyway, and then they just never went back to their campus because everything's online. But yes, there's kids coming back from winter break, and considering COVID and the fact that it mimics the logistic growth curve is all too real when we're considering this situation. But when you're looking at the formula that is presented here, I want to mention that sometimes the hardest part with logistic growth is recognizing that you have a logistic growth function. So one of the things is they can change the variables on you guys. So t is still t time here. But what is it that s represents that we normally are used to seeing? What's s? What's the variable for s that we normally see? Go ahead and type it into the chat. What's the variable for s that we would want to consider is the same as s? Okay, so that's going to be part of the trickery of all of this, is trying to, figure out, well, what part is the carrying capacity when we're looking at a formula that looks like this. So this is an alternate way of writing the logistic growth curve. So I'm just going to show you guys how to algebraically manipulate this. Okay, so if you're more comfortable with P, then you guys can rewrite it as P. So there's no problems with that. So let's say you guys wrote it as P and you're like, this still doesn't look like what the formula is that Mrs. Kim showed us, which was dp dt equals some constant over the carrying capacity, which usually is just one giant constant out front, and then PMP. So the PMP part has a minus sign in between. So we got that minus sign here. The problem is that the coefficient that, and let me change this so that you guys have, this coefficient has to be 1 in the formula that I have above. In red, I put a coefficient of -1 in front of the P at the very end of the PMP part. And then this number represents the carrying capacity. So when your formula is written so that it's 1 minus some constant in front of P here, what you're going to do is ask yourself, if you want this to be a -1 here, we can factor out this constant of 1 over 800 and see how that's going to affect the rest of our equation. Okay, so let's go ahead and do that. So this is just an algebraic manipulation. So 0.4304p is going to stay that way. I'm going to factor out 1 over 800, which is going to leave me with over 800 out front. The question is, what's going to go here? And then now I have minus 1p, which is what I want. Okay, so if you guys factor out 1 over 800, the question you want to ask yourself is, if you were to take this and distribute it to this here, you want to end up with, or the 1 over 800 that you guys took out and you distribute it to a number here that we're trying to figure out, we should get 1. Okay, so what number goes here in that spot? Okay, and think of it as reverse distributive. Yes, it's 800. So therefore, when you rewrite it like this, now you guys can see certain things up here. This value right here that I have highlighted is the value of my K. This value here is the value of my carrying capacity, which matches this carrying capacity here. And so then I can answer certain questions. Okay, so let's look at 2a first, and I'll come back to 1. For 2a, what's the limit as t goes to infinity of s of t? What's that answer? Okay, perfect. Someone wrote 800, and that represents the carrying capacity. That's the maximum number of students that would get infected in this case. So 800. Okay, so then let me go back to 1. 1's the hard question. With 1, write a logistic equation that models the number of students infected with the virus after t days. Notice that it does not ask you guys to solve the differential equation that you guys see above. It just simply says find s of t, find the number of students infected. So I'm going to do the work down below here. So it does take a little bit more work here. S of t is my missing in action formula. So if I write that out, 1 over m over 1 plus a e to the negative kt, there's going to be certain things I have to figure out before I come up with that model. I'm going to have to know what M is, which we said was the carrying capacity of 800. What's the value of K according to the formula that you guys see above? What's the value of K? Okay, good. According to the boxed highlighted portion above in the formula, we see 0.434 is the value of K. And so if I have a function, S of t, I want S to be written such that its S of t is equal to all constants except for the e that you guys, e to the negative kt. The t part is the only variable. So that means I have one other constant I need to solve for, which is that capital A. Capital A, unlike the exponential growth and decay problems where A represented the initial population, A does represent some constant, but it does not represent your initial population. However, if they give you guys an initial condition, that's going to help lead us to answer that question. So if you guys can look back at your first paragraph, can you tell me what the initial condition is that's presented to you guys in the problem? What's the initial condition in the paragraph that you guys have there? Okay, it starts with 10 students were infected. So that's always been a question that kids ask is like, does that mean week 1 or week 0? We would say week 0, like that's the initial condition as in the very start of time in this problem. So time is equal to 0. So if we go back to our equation, then we're going to say, okay, well, we know the initial condition is, let's do 0, 10. Okay, so the population infected is 10. And then we fill out what we know, 800 over 1 plus, we are trying to solve for A, e to the negative 0.434 t. Okay, and time we said was equal to 0. So all that works out nicely to where you guys have that e to the 0 parts is equal to 1. So can I have you guys solve for A for me? Go ahead and solve for A. It should be a nice clean value. Cross multiply. Good. Type it into the chat once you guys get it. Okay, perfect. So we should have gotten A is equal to 79. Okay, cross multiply and then, 10 times 1 is 10, 10 times A is 10A. Don't forget to subtract and divide. So that would have gotten you guys 79 as the answer. And then as you guys continue this, you're going to just make sure that you fill out 79 e to the negative 4.34. And we see that our only variable left is t and s as a function of t. So that's the answer to 1. All right, you guys. So that was what I wanted to cover with you guys for logistic growth. Then with 15 minutes, I wanted to make sure that you guys had a chance to go through one free response. So let me just have you guys look at your logistic growth packet that you had printed for me. And let me point out that you guys have already done that this 2005 question 6. I didn't realize that that was part of the homework assignment from the other night. And if you didn't know, all of these scoring guides are available to you guys on the web. So if you Google search 2005 Calculus A/B scoring guide, it'll come up with the how to score each one of these problems that you have with the worked out solution. So you've already done this. I'm just going to mention when you're looking at these problems, so you're, I think on tonight's homework, I'm making the 2005 required. And since you already did the top, you're good. We're going to actually do the 2004 here timed together. So this is page 5. Go ahead and flip to page 5. It should say page 5 on top, 2004 Form B. Okay, I'm going to give you guys 15 minutes here. and our class ends before that. The last class was able to finish earlier. We ran out of time as well. So I'm going to start working on the part C part. Can you guys go ahead and start working on this problem, and then I'll kind of give you guys a heads up on time. And then when you guys are ready, I know it hasn't been very much time, but if you are ready, like you're done, whenever you are, can you guys just type into the chat so I know to start reviewing? If you are done, can you type the word done into the chat? And you guys, I only gave you 5 minutes so far, so I know that's not definitely not enough time. But just to give you guys a sense of timing, keep working. By the way, keep working as I'm talking. But 15 minutes is normally the average on a free response question. So if you finish this in 5 minutes, then you finish it within a third of the time that was allotted for you. So I'm going to give it another about 4 minutes or so, and then I'm going to have you guys grade. Okay, you guys, because of time, just by the way, that was only half of the time that would have been allotted to you. I will come back to my work, but I wanted to show you guys the scoring guide. And I apologize, it's written. Actually, let me see if I can move this a little bit. So I want you guys to grade yourself on, I know some of you guys probably didn't get a chance to finish on what you have so far. So for the slope fields, because I wanted to make sure you guys have this so that you know how I'm grading things, the slope field was only worth 2 points. So 1 point if you guys had the zeros going up and zero slope going up and down the y-axis, positive slopes for above 2, and then between 0 and 2 negative slopes. So that's plus 2 points on the slope field question portion. B, I'm not too concerned with. There's no way you guys can like study for some of these questions, and one of them is B. It was only worth a point. It asks where is the slope negative and describe where it's negative. You guys can see it's negative only in 2 spots. So if you guys have described it in some way similar to B, then give yourself a point for that. So not along where the y-axis and when y is less than 2. Okay, so then C is the big one. Okay, so C on your test as well is going to be a big one. And I wanted to point out when you guys are looking at your free responses, if there's only part A, part B, part C, there should be like warning flags going off in your head that, oh, one of these might be worth a lot versus the free response questions that have like 4 or 5 parts to it. So in this particular case, this was worth 6 points. These are the things I'm going to have you guys notice is that notice that at the very bottom it says 0 out of 6 points if there's no separation of variables. So they like ignore all of your work if you don't separate the variables. So make sure you guys separate the variables. If you did, give yourself 1 point for separating the variables. Give yourself 2 points for your antiderivatives. So plus 2 for plus 1 on the left-hand side, plus 1 on the other side, so ln, and then the 1/5 part. So after that, if you did not put a plus C, the maximum number of points you could have gotten, see the note at the bottom, is 3 out of 6 because you would have gotten the 1 and the 2, but missed everything else after that. So make sure you guys do the constant of integration. And the reason is that's so that we can find our particular solution. So plus 1 for the constant, plus 1 for uses initial condition, plugs it in. And then the last point is for solving for y. And someone just asked, and I wanted to make a note of that. You do want to isolate for y and pick a particular solution when you guys are given an initial condition, because your curve has to go through that initial condition, that point. So if you go back, you'll go ahead and look at their work, and they didn't do what I would recommend, which is plug in your initial condition at this point where you have the plus C. I would say do it there, and then if your work, I think it looks confusing to me to have like the plus or minus e to the c. So if you guys look at my work, let me try to move the screen here. If you guys look at my work, I have some recommendations for you guys to keep it nice and simple for C. Like I always plug the initial condition in right after I integrated. So right after this step of integration, I would plug in the initial condition there, solve for C. And then these are some mistakes that I noticed along the way. This plus symbol should be separated into 2 exponential expressions, in which case you guys have e to the 1/5 x to the 5th times e to the ln of 2. This becomes just the constant out front. So that's that e to the c part that they have. Someone asked, do I have to pick a solution? You do, because only the negative one fits this initial condition at the start. Okay, so the initial condition being it has to go through 0, 0. And the only way that happens is 2 minus 2 works. So your final answer should be 2 minus 2 e to the 1/5 x to the 5th. Out of 9 points, can you guys type out, what did you guys get on this? Out of 9 points,